Hello everyone and welcome to my channel, Beauty Personalized. As you may have noticed, the ski slopes have recently opened in the Alps, and everyone is keen to take advantage of the best conditions to hit the slopes. But every morning, the same question comes up. What's the weather like? Are there lots of people on the slopes? To answer these questions, today I'm going to show you a Python script that does all the work for you. This project will use Selenium to control interactions with the web browser, OpenCV and PIL to work with and enhance images. And finally, we'll also use a touch of AI to analyze the weather and then count the number of skiers. In this video, you'll learn how to access a website. So here we'll take the example of the site containing webcams of your favorite ski slope. Once we've accessed this site, we'll capture an image of the web page and save it directly to your computer. Then we'll enhance its quality and visibility by adjusting its contrast and brightness. Next, we're going to analyze the colors of this new image to deduce the weather and therefore understand whether it's sunny or not. And finally, we'll use artificial intelligence to detect skiers and find out how many there are. This script is ideal for you if you're an avid skier or surfer, where there are also webcams. Or simply if you want to learn how to automate tasks with Python, including web automation, image use and editing, and artificial intelligence. Imagine waking up, running the script, and instantly getting the information you need to know about your day's skiing conditions. No need to waste time searching manually. Everything is done for you in one click. Let's take a look at an example of what we'll be able to do at the end of this video. The script opens in widescreen mode, giving us access to the live webcam. So we can see this beautiful image of the mountain that makes us want to go. We've left a time.sleep here so that we can observe this image for longer. And then the program will close. And in the console on our right, we see that the screenshot has been saved, along with the location on the PC where it was saved. Next, the image has been enhanced. The location on the computer is also shown. Then we have a weather analysis. Here we're told it's sunny because it was 40% blue, and we've detected 2 skiers. Let's take a look together. If we go directly to downloads, we can see the first image. So that's been loaded, with our 2 skiers right here that have been detected. And so now we have this image that has been enhanced where more brightness and contrast has been brought in, so that then with our AI we can more easily detect our 2 skiers right here. For example, in this video we're going to use Python and a code editor. So here you can see I'm using Spider. If you don't have them on your computer but want to code along with me, I recommend you go and watch my video installing Python and your code editor in less than 5 minutes. We're also going to be using Selenium and a Chrome driver, so if you like to follow this video by doing the same things I'm doing at the same time. So I suggest you go and watch my video, installing Selenium and WebDrivers in under 5 minutes. Now that you've installed Python and your code editor, you've also installed Selenium and the Chrome driver. We still need to install a few things. So here we want to work on images to increase their brightness and contrast. To do this, we'll need to install PIL with the pip install PIL command. Here you enter. So you can see it here. I've already installed PIL. So it tells me. Then, in this script, we want to analyze and process the images and also identify their colors or identify the skiers. To do this, you'll need to install OpenCV Python using the command pip install OpenCV Python, which you can see right here. I've also already installed OpenCV Python, so here my computer shows me. Finally, we need to install NumPy. NumPy will handle all matrix calculations, and here it's linked to OpenCV, which we installed earlier. For example, when we will define what blue is in our script, we're going to indicate it in matrix form. So we're going to need to be able to master these matrices. And so all this is done with NumPy, so we install with the command pip install NumPy. And also I've already installed it, so my computer tells me it's perfect. We've done all our installations, so now we can start our script. To begin with, we're going to import the libraries we need to run our script. So, as usual, we'll always comment our text to indicate what we want to do. The first library we're going to import is import OS. In this script, OS will allow us, for example, to save images that we have directly downloaded and captured in our download folder. It will therefore manage all access paths within the computer. Now we're going to import time, which will enable us to generate pauses in our script so that we can observe interactions, for example, when we're on the website. So we'll see the webcam and be able to observe it for 10 seconds, for example. Next, we'll use the command from Selenium import WebDriver that will control the browser and open a web page, for example. Or we might want to click on a location on the web page. This WebDriver will enable us to perform all these actions. Next, we want to manipulate and enhance the images. So we'll use from PIL, the pillow we installed earlier, and import. Here we're going to import image and also image enhance. So for image enhancement, as you can see right here with Spider, I have the automatic completion that it proposed directly at the end of this word image enhance. Next, we're going to import CV2, which will enable us to manage advanced tasks such as object detection, where in this case we'll be detecting people, but also image analysis. And finally, we're going to import NumPy as NP. So here, when you write as NP, it allows you, when you call up this NumPy library, to just write NP, and so it can simplify the writing in the script and also make your writing faster and more efficient. So here, we've imported NumPy for all matrix calculations. And here, for the definition of blue colors, for example, when we're trying to analyze whether it's sunny or not. It's perfect. Now that we've been able to import all the necessary libraries, we're going to indicate where on your computer, i.e. the path where we want to download these images we're going to capture, i.e. from the webcam. To do this, we'll create a variable that we'll call download folder, for example, and which we'll say is equal to OS. The OS we imported earlier .path is therefore the path to this OS.join. So here we want to join the user's global path with the download folder directly. To do this, we make an os.path.expand user. And here we have a symbol which is very well known in Python. So it's going to be this one. I'm pasting it here, and this symbol will allow us to say that we want to find the global path of the main user, and so here we're going to indicate comma. And now that we've indicated the user's global path, we need to add the folder where we want to save it. In this case, it'll be the download folder. Now we want to capture an image from the webcam. So to simplify all this, we're going to create a function, and this will then allow us in the final code to simply call up this function and not have 100 lines of code, which is therefore unreadable. Whereas with small functions directly, it allows us to go straight to the function to understand because there's a precise subject in this function that we've dealt with. And then it's easier to go back and make changes. Even more if you've included comments. So to declare a function, we'll use the def command, and here we'll call our function capture webcam. And here, to declare the function correctly, you need to enclose it in brackets and then 2 dots and enter. And then, indent your code to avoid generating errors. To start with, we need to initialize our driver so that we can open our browser. To do this, we'll use the command driver equal to webdriver.chrome. So if you want to use Firefox, you could do driver equal to webdriver.firefox and here in brackets. In quotation marks, if your computer doesn't recognize it here, if there's an error, you can directly indicate the path where you downloaded your Chrome driver. Then, for greater readability, in this example we'd like to open the browser in widescreen mode, and to do this, we'll use the command driver.maximizeWindow. Now we'll need to define our URL, so that the script can target it directly during the automated connection. To do this, we'll create a webcam URL variable. It will be a string. And when we look here, this is the link to our webcam that we saw earlier, so we're indicating the link here. Using a URL directly in a variable will allow us to change this URL and no longer watch this Meribel camera, for example. But if we want to go surfing in Biarritz, then we can directly change just this URL, and then everything that calls on this variable will be directly reflected without having to change the number of times we called on this variable to access the site. So now we're going to make a driver point get, and here we have the webcam URL we just created. Next, before taking our screenshot, we want to make sure that our page has loaded correctly. That's why we're going to add a little time.sleep. Here, We'll say that we take 15 seconds to make sure the page has loaded properly so that we can observe it too. Now we want to take our screenshot and save it in our download folder. We therefore indicate this directly in our comment. So how do we go about it? First of all, we'll need to specify where we want to save this screenshot and under what name. It's very simple. Here we've just defined the download folder variable, which will be our download folder, to indicate directly that we want to go to this download folder. We'll also need to create a join variable, which we'll call screenshot path. And we're going to say that it's equal to os.path.join, and here we're going to join the download folder, so we go to the download folder, comma, and then we're going to give a name to our image directly that we want to save. So here we'll say, for example, that it's Meribel webcam.png. Perfect. Now that we have the path to save this image, we want to perform the action of taking this screenshot. So we make a driver.saveScreenshot, and here indicate the screenshot path. Finally, we want to close the browser to free up our computer's resources. To do this, we'll use the driver.quit command, and then we'll want to display that the action has been carried out, i.e. that our screenshot has been saved, and we'll use the command print, in quotation marks here, screenshot saved, and here we'll put 2 dots and a comma. Then, we'll indicate the path, so here we've called it screenshot path. And finally, in each function we want to return something. In any case, that's the purpose of a function. We're not in a procedure here, so we want to return the path of the captured image. So we'll do return and here screenshot path. Now that's perfect. Together, we've created our first function, which takes a screenshot of our webcam here. Now we're going to create a function to enhance the image. So here we're going to write the function comment to enhance the image with contrast and brightness. We're going to call it enhance image in brackets, and we're going to take one argument as input. This argument will be the path of the image we captured earlier. Here we'll call it image path, for example. Here, this image path that we've created will actually be the screenshot path that we were able to return at the output of the first webcam capture function. And don't forget the 2 dots. First, we need to load the image we've captured. So we're going to create an img variable, and here we'll say it's equal to image.open. And here we have image path as an input argument to this function. So we want to increase the brightness here by a factor of 20%. So we're going to multiply by 1.2. To do this, we're going to create a first variable that we'll call enhancer brightness, and we'll say that it's equal to image enhanced door brightness, and here in brackets, img, which is the variable that corresponds to the image we loaded earlier. And here we're going to create a new variable called, for example, img brighten, which will be equal to enhancer brightness, and here we're going to enhance with .enhance, and here we want a factor of 1.2. This is perfect. Thanks to these commands, we've now loaded our image and increased its brightness by 20%. Now we want to increase the contrast by 50% this time. So, if you've been following along, you've understood that we'll need to do an enhance of 1.5. So we're going to create a variable that we'll call enhancer contrast here. And this variable will be equal to image enhance, and here point contrast in brackets, we'll put img brighten that we defined just before. So once we've increased the brightness, we increase the contrast on this new image. And so now we create the enhanced image variable, and here it's going to be equal to enhance contrast point enhance, and in brackets, a factor of 1.5. Now that we've enhanced this image, we want to save it in the download folder. So we're going to create an enhanced path variable, and here we're going to say that it's equal to os.path.join here, so still in the download folder, and we're going to say that here its name. So we're adding its name, it's going to be Meribel. And here we can say webcamenhanced.png, for example. Here we'll just rename the variable for simplicity's sake. We'll say that it's the path for better understanding. And then we're going to create this new action, which is actually going to save the enhanced image we created earlier with the command img enhance.save. And in brackets, we're going to indicate where we want to save it. So here we want to save it in enhanced path. Perfect. Now we'd like to return to the enhanced path we were able to do on the previous line. So just save the enhanced image to the enhanced path. So, with contrast plus 50% and brightness plus 20%, We're now going to create a new function that will analyze the weather according to the color of the image. To declare it, we'll write def. Here we'll call it analyze weather, and between brackets we'll say our argument will be the image path, i.e. the path to the image we've taken as input here. We'll of course take the enhanced image as the input path, and we'll of course indicate this directly in the script when we call this function. As before, we need to load the image, so we'll create a variable. Here, it's important to know that when we're in a function, we can create a new variable with the same name as in another function, but this won't affect the variable in the other place. For example, here we're going to call img, and here it's the same name as at the beginning, right here in the enhance image function. But by using it in a new function, it's as if it were actually image2. And it's as if they had two names, they're completely different, and one doesn't move the other, they're not linked. So, to load this image, we'll use the cv2 library and here .imread, in brackets image path, so the argument we have here in this function. Next, we want to convert our image into the space we'll call HSV, as it's better suited to analyzing color tones. So we're going to create a new variable that we'll call image_HSV, which will be equal to cv2.convertColor. So the source to convert is going to be img, our image that we've loaded, and the code here is going to be cv2.here. It's going to be color_bgr, and here you can see that we have a multitude of them with automatic completion. But we want to choose 2HSV. It's perfect. Now that we've converted our image to HSV color space, we'll need to define what we think HSV blue is. And so find a shade of blue that's going to be the low shade and the high shade in terms of luminosity. And then directly tell our algorithm to check whether the pixels that make up our image correspond to blue or not. And so, if it's sunny or not, we're going to create a first variable that we'll call lower blue, i.e. the lower range of blue according to us. Here, we'll call on the library. NP so from numpy and so.array in brackets and here in square brackets, we want to indicate that this matrix is 90, 50, 50. And for upper blue, the strongest shade of blue, we'll say it's equal to NP.array, and here in square brackets, we'll say 130, 255, 255. Now that we've defined the shade ranges for identifying blue in the sky, we'll create a mask to detect the blue pixels and then count them. To do this, we'll create a mask variable equal to cv2.inRange. And here we'll have the source, which will be img_HSV, i.e. our image that we've been able to convert to HSV shade. Next, we'll have the lower B, which here will be lower blue, and the upper B, which will be our upper blue. Now we're going to count the number of blue pixels by creating a new blue area variable equal to cv2. Count non-zero, and here we'll count non-zero of mask. Now we'll calculate the total size of the image in pixels, so we can then calculate the ratio between the number of blue pixels and the total number of pixels in the image. So we're going to create a total area variable equal to img.shapeOf0. So here, img.shapeOf0 will in fact calculate the height of our image that we've given as input to this function, multiplied by img.shapeOf1, which in this case corresponds to the width of this image, and so by multiplying the height by the width, this gives us the total number of pixels in the image. Now let's calculate the percentage of blue in the total image by creating a new variable blue ratio, which will be equal to blue area divided by total area, all times 100. Now we're going to assign a weather category according to the percentage we obtain. So, to do this, we'll use the condition if blue ratio is greater than 30%, then we'll indicate that our weather variable is equal to clear, sky good weather. Now we'll say that if we have between 10% and 30% blue, this will be our second condition. A leaf 10 less than blue ratio, less than 30, then our weather variable will therefore be equal to partially cloudy. Finally, we'll say that if the percentage of blue is less than 10%, our else condition, then our weather variable will be equal to cloudy or snowy. Next, we want to display the result to the user in the console with the printf, so we're going to say weather analysis. Here we'll use square brackets like this to say that we're assigning another weather variable. And then blue ratio, 2 dots, 0.2f to say that we want to have two significant figures for our percentage of blue. We close the brace, add the percent symbol, and say it's blue. And of course, we close the parenthesis right here. To conclude this function, we'll return weather. Now we're going to create our function to detect skiers, so still with the command def detect skiers. As argument, here we're going to say that we want an image path, and 2 dots, and we indent as usual. As in the previous function, we'll need to load this image, so with the variable img equal to cv2.imReadImagePath. Now we'll initialize the gradient histogram descriptor, also known as HOG, and create a variable hog equal to cv2.HOG descriptor. And now we're going to configure the people detector with HOG.setSVM detector, and here in brackets cv2.HO descriptor, and we want the people detector to detect humans and in our case, skiers. Now we'll define a variable skiers, comma, underscore which will be equal to hog.detect multiscale. This multiscale function will detect regions of the image where people are present, using a pre-trained detector. So, here we have detect img, our main image. Here, we want to move 8 pixels by 8 pixels on the image to try and detect people. So if we wanted to be much more precise, we could set a smaller step, but that would make the analysis much longer, and so the script would take longer to run. So we'll write windstride is equal to 8.8. And finally, we want to be careful not to take into account, for example, whether there's only a foot or only a border part of the image, so we don't want to have truncated people. So we're going to add a padding equal to 16:16 to leave a little more margin, i.e. 16 pixels on each side of the image. Then, at each iteration, we want to reduce the image size by 5%. So we'll add a scale equal to 1.05. So we have the detect multiscale function, which returns an array, the skier array. In this skier array, each skier will be represented by coordinates, corresponding to the area of the image where it was detected. We'll then be able to calculate the number of skiers by creating a countSkia variable equal to len of skiers. So we'll count the size of the array, and finally this will give us the number of skiers, which will then display in the console, i.e. print in quotation marks. Number of skiers here, count skiers. And then, to close this function, we'll return count skiers. Finally, we'll create a main function with the command def main, which will have no input arguments and will be used to call all the functions we've created previously. To begin with, we'll display the beginning of the script in the console to make it easier for the user to read. Next, we'll take a screenshot of the webcam by creating a screenshot variable equal to capture webcam. Next, we'll enhance the image we've retrieved by creating an enhanced image variable equal to our enhance image and screenshot functions. Next, we want to analyze the weather. So we'll create a weather report variable. This will be equal to analyze weather of enhanced image. Next, we want to detect our skiers. So we'll create a variable called skiers count, which will be equal to detect skiers in enhanced image. Finally, we'll create a summary variable that will display the overall results of our entire script, such as the number of skiers or the weather with the percentage of blue. So we're going to say that this variable is equal to f, and we're going to put 3 quotation marks so that we can go to the line and have these carriage returns taken into account in the print display. We'll write summary of Meribel, then weather, and here we'll put weather report in braces, then number of skiers detected. And here we'll put our skier count. We'll add a for more design. And finally, we'll close with 3 quotation marks as well. Then, we'll display this summary variable with a print summary. Finally, we'll call the main function, which in turn will call all the other functions here. Just before launching our script, we're going to add 2 parentheses here so that there are no errors, because we're calling a function. We need to tell Python that. So we launch our script. The script is launched, and as we can see, it opens in a large screen, so we can see the webcam. By the way, the weather's not very nice today. And so, normally, our script should tell us that. It tells us that the screenshot has been saved with its location. It currently tells us that it's cloudy and snowy with 0.37% blue, which is what we've observed. It also tells us that 2 skiers have been detected. So let's take a look at the downloaded images. We have our first image right here, which was downloaded directly to the webcam. So you can see 2 skiers in the distance, and then here, we had more contrast added to help our AI spot skiers and also more brightness. So the script performed as we'd hoped, and we're very happy with it. In just a few simple steps, we've managed to create a tool that lets you automate your ski days. It checks the weather, detects skiers, and lets you decide in seconds whether it's going to be the perfect day to hit the slopes. Honestly, who doesn't want an assistant like that by their side? Of course, there's still room for improvement. For example, we could add a feature that sends an email every morning at 9 o'clock. We could also train the AI that detects people ourselves, because it's used to detecting people in the street, for example, and not specifically on snow, so with very strong white colors, and so it can sometimes make mistakes. To make it even better, we could also add other ski resorts, or surf resorts, or many other activities that have webcams. This project is also a great example of what you can do with Python to solve real problems if you're passionate about automation, AI, or simply developing useful skills. This kind of project is a perfect opportunity to progress. If you've enjoyed this video, please consider liking it to support the channel, subscribing so you don't miss out on future Python projects, and also sharing this video with ski and technology enthusiasts. If you want to go even further, I've put together some comprehensive training courses in French and English on Udemy, covering web automation with Python and Selenium. And for Christmas, I've put together a promo code for my subscribers that you'll find in the description. Thanks again for watching this video, and I'll see you soon for new adventures in Python and Selenium.